Good evening and welcome back. So in this lecture we will be running through this function here, the primary fire function, inside of the BP player. So as per usual, if you don't have the player blueprint opened, go ahead and open that now. When you're in here, if we just double click on the primary fire function, that will take us to its graph. And this will be slightly different from the other function that we've made. The first difference being that it will not need a return node. We simply want to allow it to do the functionality and we can leave it there. Whereas this one up here, we were doing the functionality and then we were getting a value out of that, and it was actually the value afterwards which was important. The second difference is this function won't be used for reusability, which is another important thing, is remembering that if you can reuse something, it's probably best as a function. So in the get direction, we're doing everything once, but we're able to call it in multiple places. Now we will be able to call this in multiple places, but the difference is we don't need to. But it's still tidier having it in a function, and at a quick glance it's just easier to see what it's doing. And also this is quite a large amount of blueprint as it is, kind of as condensed as it can be without going over the top. So the easiest way to tidy things is to split the different types of projectile up. So I just wanted to kind of make it clear that not every time does the function need to be used just when you're going to call it more than once. Sometimes it can be purely a functionality or tidiness kind of approach to do things as well. So if we return to the primary fire function, what we want to do first of all is to give it a single input. So we won't have any outputs, as I said, but we will still have an input, and the input we're interested in is of type scene component. So we want a scene component and we want a reference to the component. So these blue nodes that we've been getting so far, they're references to something, and we're just going to rename this, and we will rename this spawn location. So the spawn location will be simply the location the projectile spawns in the world, and just remember this setup because we're going to be doing this again for future functions that we add. So we want a scene component for the input. So just remember that. And then from here, what we will do is we will get the world transform of the scene component that gets passed to us. So get world transform. So this will give us all of the values within that scene component, which will be its location, its rotation, and its scale. So that's what a transform is. A transform is a set of values which you could also get separately, but this gives us all of them in one place. And remember, because we are passing this as an input, the function itself doesn't actually care what spawn location is. It doesn't need to know about it beforehand, it doesn't need to know what it is or anything like that. It just needs to have a value passed to it, and it will get some values from that and then do what's required. So with that done, from the get world transform, we're going to pull off again and we will break the transform. So now what I just mentioned is that we get the location, the rotation, and the scale. We now have access to all of these. We can actually leave the scale as it is because we know that everything's been scaled uniformly, so this will be a scale of 1. We do want some more information on the location, and to get this we just simply right click on the pin and we split the structure pin. So now we have the X, Y, and the Z of the location. We also want the rotation, but we can leave this combined because the rotation will take the whole value. We don't need to do anything with a specific axis. And with this done, we want to make transform. So this one's broken the transform so we can get the values from it, and this one's going to make a transform. So it's going to put them all back together so that we then have a return value of another transform to pass off as the final value. And what we want to do is, again, we're going to have to break or split the structure pin for the location in the make transform. And most of the values we can just pass straight across. So the X and the Y will be the standard X and Y for the component we pass in. The rotation will be the same, so we can just pass that straight in. And the scale doesn't matter, they're both going to default to 1, so we don't really need to pass that across. The only thing we do want to change is we're going to drag off of the Z axis and we're going to plus a float by a float. We'll just quickly plug this into the other side, so whatever the return of this equation is will be plugged into this part of the transform. And what we will do is, from the bottom node, we will then get a random float in range. And the range, I'm just going to make an arbitrary number for the time being, so I'm going to get -70 and 70. So if you may have already worked out what this is doing, if you just look at what's happening, this is controlling the spawning of the projectile. So we're giving it a position in the world, and what this is doing is taking the current position of the spawn point where we want the projectile to begin. We're getting the z-axis, which if you remember is up and down the screen, and we are either adding or minusing a value between -70 and 70, which is picked at random. So what this will give is a small amount of variation when the projectile is fired. It won't always appear in a perfectly straight line, so if you do want it to appear in a perfectly straight line, just remove this bit and just you can just plug the location straight across like we did the rotation without breaking it or splitting it. But I quite like the idea of having some slight variation, because again it just gives that hint that you're not firing in a perfect straight line, which most weapons or ships won't. You're going to get a little bit of air resistance, you're going to get a bit of movement, a bit of kickback, and all of this can kind of be hinted at by doing a very small offset when the projectile first leaves the ship. So that's what that's doing. And actually I said that if you didn't want the slight offsets, you could just remove that and pass those across. If you didn't want the offset, you could actually just use this value straight into the final thing we'll be plugging in a moment. So I'll go back to that in a minute just in case. So then from here, we're going to go back to the start node. We will pull off of this pin and we will get a spawn actor from class. And all this does is simply, once this has been called, it spawns an actor from a class, and the class will be things like the bpPlayer, or later we'll be adding a BP projectile, and that is what we'll be spawning in here. But as we don't have that at the moment, we can just fill this. Actually, if we just fill this with something silly, like we'll use the bpPlayer because we know it works and it exists. So this means that if we start trying to fire the weapon, we'll be reminded that we haven't completed this yet because we'll be firing players. So it'll just give us a heads up that we've probably forgotten to fix the projectiles. And then as you've seen, you just plug the return value into the spawn transform. So this will say spawn an actor of a certain type and spawn it at this location. Now if you didn't want my offset thing, then you would simply remove that and just plug it straight from the get world transform of the spawn location. And that's really as difficult as that function needs to be, but as I said, I do like to add that little bit extra. It just makes the game feel a bit nicer in my mind. Okay, so that is the primary projectiles setup, and if we go back and compile that and go back to the event graph, what we can do is we know that the projectile spawn point we want is the projectile spawn we made earlier, the scene component, and remember that that's exactly what we're getting. We're getting a scene component, we can see that says it there, and this is a scene component, so that's why we had that ready for use. And all we need to do is plug that up into the spawn location, and that now has a point in the world of which the projectile will be spawned from. So if we go to the viewport, just to reconfirm this a bit more, the spawn point is that section there just in front of our ship, and obviously we're going to get a +70 or a -70 offset, or some point in between that every time we fire. So if we compile and save that, we should actually have that available now. Oh, I know what's happening. So because we're firing the player ship and the player ship's a bit too big, probably not the best thing to test it on. The default collision handling will probably be stopping the pawn from spawning because it's collided with something. If we say always spawn and ignore collisions, go back in, compile and save. If we try and fire now, there we go, we get given the players regardless. So that looks a little bit strange, but you can see it's working and we're spitting out player ships, which looks bizarre. So I'm going to stop doing that. So there we go, that's just the only thing we wanted to change, is to make sure that always spawns regardless of the collision. But we now have our first projectile firing. It's not doing the exact correct thing, but it's working as planned, minus the fact we don't have a projectile. So I'll leave that there for this lecture, and I will see you in the next.